Hi, this mineral is sometimes called blue gold. It doesn't look like much, but it's an incredibly important mineral. A mineral that's so important and so valuable, people can and do kill each other for access to it. You might know it as something else. You may have heard of a mineral called coltan. Coltan is actually a combination of two minerals. Columbite, which is an iron manganese niobium oxide, or tantalite, which is an iron magnesium tantalum oxide. There are two metals in here that are really important and incredibly valuable: niobium and, in particular, tantalum. Tantalum is an essential component in all electronics. It's used to make capacitors, things that will store a charge so you can have an instant availability of electricity in an electronic device when you need it. Every modern electronic device contains tantalum. But where it comes from is perhaps where the issues arise. See, coltan is an example of a conflict mineral, a mineral that people will fight for control of, fight to control the supply. What I want to do in this lesson is consider where mobile phone elements come from. Where do all the elements that we've looked at as part of this sequence of lessons actually originate? Because each of these elements must come from a mine somewhere, where a hole in the ground where there's a concentration of that particular material. Now, for this lesson, you're going to need an atlas and you're going to need an ore mineral datasheet. If you look in your booklets, you'll see that you have a blank world map. This world map is something I want to try and populate with the sources of all those elements that we've identified from a mobile phone. This is an extract from the ore mineral datasheet. It shows each of the elements in alphabetical order, also the mineral or the minerals that are the main sources of those materials, and also the largest producing countries. You'll see some of these I've listed 4. There are generally more than that, but others I may only have listed 1. That means that virtually all the world's supply comes from that one country. That can create a whole series of geographical issues in itself. There are some, like arsenic here, you can see where virtually the whole of the world's supply of arsenic comes from just 3 countries. So, what I want you to do with this, I want you to produce a map to show the source of these elements. And to do that, there are 2 things I'd like you to do. Firstly, I'd like you to shade in the countries that produce these elements. They can all be in the same colour, but I want us to see the geographical spread of the minerals that are in your mobile phone. I'd also like you to label up each of the countries that you shade in with the chemical symbol for the element that we get from that country. Let's look at the first 2 to start with. So our first element is aluminium. The main ore of aluminium is bauxite. And the four biggest producers, they're not the only ones though for aluminium, are Australia, China, Guinea, and India. So if we then, on our map, shade in the countries that produce aluminium and label up those countries with the chemical symbol for that element, we can start to put our map together. If we look at the second one then, antimony. Antimony we almost entirely get from China. So there we've already shaded it in, but we can label up SB, which is the chemical symbol for antimony, onto China. What I'd like you to do now is I'd like you to complete the rest of that map. There's a lot of information there. You will see a lot of the same countries appearing time after time. Places like China, for example, are a major supplier of these critical elements. So be careful how big you make your labels. Use the atlas, use the data sheet, and complete that map. Okay, press pause now and have a go at that. Okay then, let's see what we've come up with. So this was our blank world map. Let's start by shading in the countries that are the main producers of the elements that we find within a smartphone. You can see that there's a wide variety of countries from across the globe that can be providing the elements that are in the phone that's in your pocket. If we look at where those elements come from, you can see that there are some countries that are major producers of elements that we need to build modern electronics. So we can see that there are some countries here which are significant suppliers. The USA, Brazil, Australia, Russia, even Japan. But perhaps the biggest supplier of them all is China. If we were to think about even just the minimum number of countries that be required to provide all the elements that we need for our mobile phone, we can see perhaps a slightly different pattern. The major countries that we've identified there would provide all the things that we need. The question is, would we want to be reliant on those countries to provide those elements? So these countries are critical to the world supply. China in particular mines out the rare earth elements that we need to have to make electronics, to the extent where they can almost entirely control the world supply of several of these critical elements. The European Union currently is going through a project to identify European sources of these elements to try and ensure a security of our own supply. These are the rare earth elements. These are the ones that modern electronics will not work without. They need a small amount of each of these. One of them in particular is really useful: neodymium. Neodymium creates extremely strong, powerful magnets in a very light form. It's essential for small speakers, for example, and other industrial uses. If you get a chance, watch the video on the race for neodymium. But perhaps this is the most important of all. This particular mineral, zabulayite, this example's from Bolivia, is lithium carbonate. The batteries in all electronic devices and also in electric vehicles are made out of lithium. We use lithium because it's the lightest of all the metals. So any mobile device, anywhere where we want to use electricity on the move, we need a large amount of lithium. We can't recycle it. 30 years ago, we hardly used any lithium. It virtually had no uses. It was too unstable, too soft. But now, because of that lightness, bonded with other elements, it can act as our source of mobile electrical power. We need to find a lot of lithium. It's out there, but we need to find it, and perhaps more challengingly, we have to persuade people who live in those areas that it's a good thing to dig this mineral out. Even people who would rely on having that supply of lithium for their own devices. It's going to be a really big challenge over the next 30 years. But for now, we've seen where these minerals come from. We know what minerals are there. We need to learn about how to find them and the rocks that we find them in. But that's for another lesson. I'll see you then.